My first programming language was Fortran. In those days, computer code was a series of straightforward logic statements, definitions, input, and output. With this resource, we could keep track of numbers, especially money, do complex scientific calculations, and put a man on the moon. The program was self-contained. I go into a Home Depot. What is the programming behind the cashier with his laser barcode reader? The program needs to find the specifics of the product, fetch the price, and lower the inventory by 1 unit. The old linear logic will never work. In any field, we are climbing on the backs of those who went before us. It is as if the programmer, let's call him Zachary, asks for help. The resources available to Zachary are incredible, but he must follow a very specific and even weird set of rules. For example, the cashier reads a barcode from a can of paint in a Home Depot checkout line. Zachary needs help, finds a software package, gives the barcode to this software package, and gets a name, price, and whatever in return. Zachary's program has sent out information and accept return information. The help is created by a team of programmers, and the specifics are completely arbitrary. My guess is that the barcode is turned into a 10-character code, even inside the scanner. That very specific identification number is sent to a team of programmers that Zachary has never met. But his computer program receives back the name and the price. Zachary formats and creates the bill for the customer. The help that Zachary relies on is called modules, and the modules are stored in libraries. Zachary's computer program starts by reaching out and finding this help. Computer programming is all about these computer modules and conversing with them, and the computer modules are incredibly complex, developed over even years by even dozens of programmers, but Zachary does not need to concern himself with any of this. I want to move straight into an example of object programming. This Python program has only 60-odd lines. It accepts a numerical input from a USB port, adds a Unix timestamp, puts it into a database, and the programmer wants to include the name of the Python program for his internal records. This requires 4 modules: datetime, sys, serial, and SQLite. Import datetime. This allows the programmer to just grab the Unix timestamp. Import serial. Under old school programming, this would have to be like under the hood of the hardware. With this module, the programmer makes this statement, and then the input actually occurs with this line. Import sys. Google tells me this module provides access to system-specific parameters and functions, or whatever. To add the name of the Python program just requires this statement. Import SQLite. We want to look closely at this database application. The first and only reference to this module is this line. SQLite 3 Connect is the language of the module. Database January 2024 is the name of the database, and con is the label created by the programmer. So the C is associated with this database. This module will find the database, and if it is not to be found, it will create it. The database must be in the same folder as the Python program, or a different structure is needed. Bear with me, database applications are everywhere in computer programs. Con refers to the cursor in the module, and C is a label created by the programmer. C is the working thing. A database file is like an Excel file. Excel files have sheets under them. The database has tables under them. This line creates the table. Notice the very specific structure of the statement. name of the column, data type, column name, data type, column name, data type, etc. And finally, to add stuff to the database, use this statement under the C. These values correspond to the column names. These values are the variable names from the program. Notice these question marks. The number of columns, variables, and question marks must match, or the computer will throw an error. Our new world of computer programming is all about climbing on the shoulders of other programmers. By carefully following the directions of these unknown programmers, we can tap into resources of teams of dozens of programmers over years and even decades of development.